Good morning there in India. Can you hear me okay?
Yes, sir. Yes, sir.
I'm doing good. Just give me a second to adjust the room illumination because my room is kind of... I'm in Poland right now and I need to adjust my hotel room. Just give me a second.
Yes, sure, sir.
Okay, let's see if you can see me all right. You can hear me okay?
Yes, sir.
All right, well, I guess...
Recording in progress.
Can you proceed, sir?
Yeah, I can see everybody there in the auditorium. Hello, everybody.
Hello, good morning, Professor.
Good morning.
Good morning. How are you?
I'm doing good. Is this Dr. Prasad?
Yes.
Okay, very nice. Yeah.
So glad to see you there.
Yes, good to see you all there in the auditorium. Yeah, I wish I was there in person, but this is equally convenient. So
Anything you can share your file now.
okay, yeah, all right. Just give me a second.
Yeah, better. Now you will do the proper introduction and then you can take off.
Okay, that sounds good.
Thank you very much, sir. A very good morning to all to the second day of International Conference on AI-Powered Technology for Sustainability, AI-PTIS-2024. Hope you enjoyed the day one of the conference. Today we're having two keynote lectures. That is one in the morning from 10:15 a.m. to 11:15 a.m. by Professor Milind Wikire, Civil and Environmental Engineering, University of North Carolina, Charlotte. And second in the afternoon from 2:15 p.m. to 3:15 p.m. by Professor Deepak Garg, Vice Chancellor, SR University. Now, I would like to introduce our esteemed keynote speaker in the morning session, Professor Milind Wikire. Dr. Milind Wikire is Professor of Civil and Environmental Engineering at the University of North Carolina at Charlotte. He directs the Energy and Environmental Research for UNC Charlotte Energy Production and Infrastructure Center, EPIC. Dr. Wikire holds a PhD from the University of Wisconsin-Madison. After 6 years of engineering consulting work in the US and New Zealand related to landfill projects, he joined the faculty at Michigan State University, where he became known for his research in the areas of landfill engineering and electrochemical technologies for treating impacted areas of landfill engineering, impacted groundwater and industrial wastewaters. After 12 years at MSU as a tenured faculty, Dr. Wikire joined UNC Charlotte EPIC to lead environmental research. Dr. Wikire is the recipient of Croix Medal and Outstanding Service Awards from the American Society of Civil Engineers and the Alpha Technological Award from the Engineering Society of Detroit for his research on environmental sustainability of landfills. He is a board-certified environmental engineer, BCE and Diplomat in Geotechnical Engineering as certified by ASCE Geo Institute. Dr. Wikire has published over 120 technical papers and is a recipient of 3 US patents related to liquid recirculation and treatment systems. He actively serves on the number of North American and international conference committees related to environmental issues. A very good morning to Professor Wikire. Over to you, sir.
Okay, well, thank you very much for the introduction. I appreciate that, and I appreciate the opportunity to be a keynote presenter at your conference at GMRIT. I have been to GMRIT a few times now, and I really enjoy visiting you all there. You got an amazing campus and great students, and it is really a great opportunity for me here. I happen to be at a conference on sustainability in Poland, and what a coincidence that you're also doing a sustainability conference in India at GMRIT. So I guess sustainability has been probably a very common theme in the world, all over the world, and I know India is also doing its part now, which is great because the field I work in a highly hands-on type of projects, boots on the ground. So having an opportunity to talk about my research and how it applies to India, hopefully at least my vision for India, I'll be able to share and you'll appreciate. I know there's a diverse background of attendees in this room. You're not all civil engineers, you're all from different backgrounds. A lot of you from maybe different parts of engineering, including computer science, and we need all of your skills. Even though my presentation you may find more in tune with somebody with an environmental engineering background. And hopefully you can connect some of my thoughts and my vision, at least for the challenges in India, with some of the solutions for India through AI, because I know India is definitely develops and graduates a number of experts in the computer science field. So hopefully they can use that power using AI to fix some of the problems India and all other countries are facing. It's not just India is the only country which has some of the environmental challenges that I'm going to present, because the challenges I saw across the world in the last 2 days at the conference where I am are equally, important and challenging. So with that, before I go too far, hear me okay?
Yes.
Okay, very good. Excellent. Let me advance to the next slide here. All right. Just to do a brief, my journey, at least my perspective, my journey, not so much, what you heard about my bio, but, when I was a graduate student, and I don't know how many students we have in the audience there, and you may have some graduate students attending, and I'm sure there are some faculties in the attendance there. But when I was a graduate student, I remember living in India almost 35 years ago. And at that time, of course, sustainability was not the word we used. That time it was just engineering. Everybody wanted to be an engineer or doctor. And that time computer science wasn't necessarily the number one in the respects I see now. And I remember I wasn't really sure. I just thought maybe I'll come to the US and learn something. I wasn't really sure what I'm going to learn. To be honest with you, when I look back, certain things happen for a certain reason. And I actually worked in the consulting industry in India for a year at Tata Consulting Engineers. Then I did a PhD and master's in the US, and then I ended up working in the US, working in New Zealand for 3 years while I was in the US. And then I came back to the US as a faculty. And, that has shaped my vision because I wasn't a typical just a student and then became a professor. I actually had worked in industry and I saw things very differently. So my research has a lot of industrial slant, and I see the challenges in a much different way because if you see a challenge, you got to really see a solution. Otherwise, just looking at a challenge, there's no point. So I think there's a lot of work ahead, and I think over years when I visit, especially GMRIT and other Indian universities, I really feel that my mission is, my purpose would be to share my experience and get faculty and students motivated to work towards how we can not just generate wealth, but also make sure we can have clean water and clean air for the future generation, because that is going to get challenging every year from what I see happening. My research, my area of work is fairly narrow because I know there is an array of experts in the room, and I only represent a very small slice of expertise. And I just wanted to kind of clarify my expertise. A lot of my work in the past has been focused on waste and water interface, because in the United States and even in New Zealand when I was there a long time ago, the protecting groundwater is an important part of regulations. Can you hear me okay? I think I heard some noise.
Yes,
so,
yes.
Okay. So a lot of my work has been actually hands-on work. It's not necessarily all software-related work. It's all actual hard field work using sensors in the ground, looking at emissions from into the air, looking at contaminants going into the groundwater, and quantifying the emissions to enhance the technologies to improve the quality of air and water by reducing the emissions. So one of these research areas actually deals with quantifying recharge. That means how much water which we receive from rainfall every year becomes recharged, and how much it goes back to atmosphere, and how much we actually consume. Because as the population is going up, the consumption of water is going up. And as the global warming, you see the temperature trends. I don't know whether you feel that, but definitely I feel like every 10 years when I talk to people, I see the temperatures have gone up. So with the changing temperature, the loss of water from the ground has enhanced too, as well as the consumption. So when you look at that, the net effect is we may run out of water, not necessarily in the next 10 years, but I don't think we have put a number on it yet. If we do nothing about it, how much time we have. And I think that part needs to be handled very much by experts, and we need to train these experts. We need to have the students learn about these techniques. So that's kind of the mission of my talk today, is how can we use this presentation to go back to the classroom and get more experts produced in our classrooms. When I look at India, and when I see a lot of Indians who immigrate to Europe as well as the United States, because I'm at a conference with a lot of Indians coming from Europe as well as from other countries, the first thing I see the profession they dominate is IT, the technology. It is IT. It's software related. When I'm in India, of course I notice IT, but I also notice physical infrastructure related work, roads and bridges and anything above ground. What I think we need definitely is more environmental driven career interest. That interest, and I think there is opportunities. It's just the opportunities have not been taken up, or I'm not really sure. But we need to generate more passion for careers in environment, which is equally challenging, equally could be lucrative, because there is so much room for improvement. So if we can achieve that over time, I think I would have served my purpose. That's what at least I believe my vision is. So with that, I'm going to present some data to you related to waste and water issues in India and in the world, and hopefully you can take maybe 2 or 3 points out of my presentation and go back and motivate the people you need to motivate and do your job. As you may have seen, a lot of my expertise developed with landfills, and landfills is the interface of air and groundwater. And in that process, I have learned a lot about what we need to do and what the challenges are. Just to put the numbers, India has about 1 billion people, which generate 62 million tons of waste every year. These are annual numbers. And just to give you a perspective, in the US, we generate about 300 million tons, and the population is about 1/3, maybe 1/4. So US generates a lot more waste by far per person, almost 4 times more than India. But just putting in context, 62 million tons generated in India, 19 million tons are leaked, that means they're not collected, they just decompose in your surroundings, somewhere, it's not managed, so 30% is not managed. And 43 million is somehow connected, and there's quite a bit of recycling in India, naturally occurs, which is great. Almost, is about 20% is recycled. And then 31 million tons ends up in poorly managed landfills or dumps. Most of them are dumps, they're not landfills. When I say landfills, I'm referring to an engineered facility which has liner, which has gas collection, leachate collection, so the contaminants are not leaking into groundwater. They are not emitted to the air just arbitrarily. They are managed, that means they are treated and then they are discharged. So just to put in perspective, that's almost 60% of the garbage we have few landfills. So India has few engineered landfills. And I know I was involved in the design of the Mumbai landfill. That was almost 15 years ago now. Very small landfill compared to the size of Mumbai. I have had no involvement in other cities, but this is about 10 landfills in India which are lined landfills, which have similarity with the US landfills, which is a very small number of landfills, by the way. When you think about, I'm going to put some numbers in perspective for you to understand. 10 landfills, that's too little, because there is probably another 100 dumps which are not landfills, which are impacting the groundwater, impacting the air in India over the last few decades. And if we don't improve that, it's going to keep impacting the water and air in India. Just to put in perspective, like I said, India has 60 million tons of garbage generation. US generates about 300 million tons. About 50% of that goes to landfill in the US. About the same here, 50% goes to landfills in India. But as I said, only 9 landfills or 10 landfills are engineered. Remaining are dumps. In the US, there are about 1,000 engineered landfills. So that 150 million tons goes to about 1,000 landfills. In India, 32 million tons goes to 10 engineered landfills and many dumps. So if I were to proportionate this, India needs about 200 engineered landfills. Now I know if India has more recycling, you don't need 200, but maybe you need 100. But India is at least short by 90 landfills, if not more, to manage the waste so it doesn't end up in the groundwater. If the contaminants do not end up in the groundwater and the gas emissions are not uncontrolled. So this puts in perspective, hopefully, the need for how much expertise is needed in the arena of waste management in India. And this is where some of the decision-making process could be done with the expertise of all the disciplines, including AI. For example, you may have seen in the news, Ghazipur landfill in Delhi, and there are landfills like this. These are actually dumps. These are not engineered landfills. They are on fire, and that's because the waste is put in a dump, which is not compacted. And when waste is exposed to oxygen, it decomposes in the presence of oxygen, produces a lot of heat. If it is managed properly by compaction and proper controls of covering the waste, this would not happen. The problem here is the air pollution. This is a lot of plastic, a lot of metal, all sorts of streams of contaminants are released to the air. And it's a hazard for health. It's a serious hazard. And I think this is what needs to motivate students to pursue careers in environmental engineering, where there are funds and there are opportunities in India, substantial opportunities given. This is an uncontrolled dump, and this kind of thing exists in different parts of the world, not just India. But India definitely, with the population growth and relatively few number of engineered landfills and a waste management collection infrastructure in place, this challenge, if not managed now, it could become even much more high risk for the health. It will increase the healthcare costs in India. It will decrease the productivity for Indians. And I think this must be one of the top agendas in all universities in India, where there are presentations made to the students, especially at the first year, to motivate them to pursue careers which are diverse and their interests are diverse, and they are not focused and skewed towards a single or two disciplines. So how do we do this sustainable management in India? What do we do? Well, I don't know, in many countries, there are all sorts of waste separation. And I know in India also there are some cities which are doing this, where the waste is separated at the household level, because once the waste is mixed and it goes to any facility, it's very hard to separate. Like I'm in Poland right now, and there are 6 garbage bins here to separate all sorts of different plastics, different glass, different metal, food waste, paper waste. Now I know that 6 may be unmanageable for certain countries. Even in the United States, in the most cities, even including where I live in North Carolina, we only have 2 garbage bins. One is the garbage which is not recyclable, and one is recyclable, which is paper, plastic, metal, everything all in one container. and that is picked up separate. I know Germany has almost 8 different bins. Japan has a number of them. For India, I think we should at least need 3 bins, 3 garbage bins at household separation. Recyclable materials, then we got a biodegradable material, which is food waste, and then which can be composted, and stuff which cannot be recycled is not biodegradable, it goes to an engineered landfill. This will reduce the amount of waste going to landfills and just being scattered in the environment. So 3 different bins, and some of this I believe is happening already in Bangalore and other cities. So some of what I'm saying, maybe you already noticed happening. It just needs to be at a broader level, at a national level. And I think the universities play a key role here in getting the expertise and getting the word out. So the recyclable waste, which is, the recyclable market is already established in India because India has already a lot of recyclers. Because a lot of garbage is, recyclable garbage is sold in India. So that part is already there. The biodegradable fraction, which I believe India needs to manage easily because it has a value. Biodegradable fraction, for example, here I'm visiting one of the composting facilities in Warsaw, Poland, and all the food waste from the city goes to a composting plant, and then they convert it to a compost, it is bagged, and it is distributed to farmers. And the farmers use that as a fertilizer, which happens to be organic fertilizer if it's coming from household. So that biodegradable fraction can be composted, and as long as we have infrastructure to distribute this composted fraction, and that can be created, that supply chain can be created. And this does require expertise beyond waste management. It requires expertise in finance, it requires expertise in industrial engineering. You can use software expertise to develop the distribution system. So there's a lot of expertise needed to make this happen, where the waste is managed sustainably by recycling, by separating the biodegradable fraction, and then the rest goes to landfill. The landfill portion is the one which will take time for India because landfills do take quite a bit of budget, and they do not generate revenue. The amount of gas they generate is relatively small to convert to revenue. So the landfills, unless the people are willing to pay the tax money to put the waste in the landfill, that may take time. But the rest of the stuff, recyclable and biodegradable stuff, should be happening because there is a lot of market for that, and that can pay for itself. So, once it goes to landfills, my vision is, of course, I do a lot of teaching of landfill design in the US, and I go all over the world and teach short courses on landfill design because some in the world, the landfill design expertise is lacking. But that can be done. India has some great engineers. Some of the landfills produce gases which can be converted to energy. And if the landfills, the leachate is managed properly, and there are technologies I have developed, and there are people in the world have developed to manage the leachate, there will not be any emissions from landfills, and that will really impact the quality of air. And I think that to me would generate a sustainable waste management pathway for India, is to look at the very basic, how the waste separation, collection, and distribution can be looked at, and a whole economy is created around waste. So the waste is not looked at as waste, but it looks as a resource. Just like many countries are doing that, and looking at it as a resource because that material will have value. In fact, even the plastic, which is going to go to landfills, eventually will have to be excavated because we'll be running out of plastic at some point on Earth as we run out of oil. So that kind of value of plastic is going to go up, and the plastic which is buried in landfills will be mined, and that will become a valuable resource. So it's really important to have that resource packed in certain places, not scattered all over. So you can retrieve it, and you can convert it, monetize it. What are engineered landfills? And I know there is a GMIT has environmental classes they are offered, and I'm not exactly sure how much is the focus on landfills, but I thought maybe I will give a quick introduction of landfills. So those in the audience which are from other disciplines, maybe you'll see elements of this that can be covered in their engineering classes, because I think it's really important to develop the next level of expertise in India, which is able to design landfills, look at the environmental emissions, and that expertise needs to be enhanced, and that can be enhanced by having that kind of knowledge distributed to the students. So a typical engineering landfill has a lining system at the bottom, and the waste is compacted. It's not just loosely placed. So the air cannot enter the landfill to create the heat. That's what you see on landfills on fire in Delhi and Hyderabad and some of these areas, is if you place the garbage and compact it, so you're using that footprint very wisely, and you are using the footprint to enhance the life of the landfill. So when you compact it, you get a significant amount of life from that footprint. And the landfills also have gas collection systems, they have leachate collection system, and the liner is impermeable, relatively impermeable, it's not perfectly impermeable, so which prevents the contaminants from the waste going into the groundwater. And the gas which is collected from the garbage, decomposition of garbage, is almost 50% methane, which is a fuel, as you know, it's a hydrocarbon, and 50% is CO2. So when the methane is burnt, of course, you're still going to have CO2 emissions, but it is a lot better than just methane released to atmosphere, because methane is a highly potent greenhouse emissions gas, and the methane is a fuel. So converting the methane into energy is actually a resource, it's a revenue source. So I think introducing landfill as a waste management strategy in every Indian engineering environmental classroom, to me, is vital. It's very vital to develop, because usually Indian infrastructure for landfills is bare minimum. You've got only 9 landfills, 10 landfills, and there's a need for at least 100 more. It should be rolled out in the next 10 to 20 years, and these landfills should be paid by the people who put the garbage in the landfill, by a small amount of tax collected and applied to building landfills and operating landfills. This is a model landfill in the US, one of my research sites, this is located in Texas, Austin area here. And so what does this landfill has? Well, it has a liner, which has a clay and a geomembrane, which is a geosynthetic material. The landfills are usually, waste is compacted, and the slopes are not steeper than this. None of these dumps in India which I visited, they could be very risky, because the slopes are so steep that these landfills and they're having a lot of cases of landfills sliding and people dying in the neighborhood, because these landfills are huge. If they're not properly compacted and the slopes are not managed, this can be a hazard, because they can have slope stability problems, and you can have the whole garbage basically caving in the surrounding areas. And so teaching engineering, landfill engineering, takes expertise from all different disciplines, not only from civil engineering, chemical engineering, environmental engineering. Some of it comes from land development or building information system management, because there's a whole architecture that goes around the landfill. Landfills usually would reach heights of 200 to 400 feet if properly managed. This can be very safe. Some of the landfills I designed in the United States are almost 600 feet high in California, because they support the big cities of San Francisco, and in Florida they support cities like West Palm Beach and Miami, which are big cities, and these landfills can be very big. The reason the landfills are big is because once the landfill footprint is acquired for landfill, the neighborhood does not want to live near a landfill. So the owners usually keep occupying the land, and the landfills expand. So when they expand, you can really make these landfills very tall and actually decrease your operating costs, because you're getting the scale of economy. So instead of having a number of small landfills, having fewer larger landfills which are managed properly is how US is doing it, to keep the cost down and to control the emissions. In India, depending on the road infrastructure, this can be achieved, and you can use AI, you can use artificial intelligence with some of the GIS information system to figure out what would be the optimum locations for landfills. What would be the optimum location for taking the waste from city centers where the population density is high to areas which are not, which are at the outskirts but not too far away, and which are optimum distance for transportation. So this is where you can use a lot of computer science skills India has to figure out which areas should be zoned for landfills, which areas should be protected for groundwater, where the recharge of the groundwater occurs. This is where the water is supplied to the communities, how those areas can be protected so there is no contamination in those areas. This is where you can use AI to its full power to make the decisions. If I keep going down this list, you get an idea basically that every component of the engineered landfill is managed, is designed by an engineer. There's a leachate collection system where the leachate is collected and treated. The gas collection system, which is collected and treated. The gas collection, you need a sophisticated blower system, which is a mechanical device to pull the gas, and you burn the gas into an internal combustion engine. So there's a lot of mechanical engineering involved. It's not just civil engineering. It's a lot interface of a lot of disciplines which are at play to protect the environment by constructing and managing the proper engineered landfills. At the end of that, when you have proper engineered landfills, you're protecting the groundwater, you're protecting the air quality, and you're making sure it is protected by monitoring it. So there's a lot goes into the engineered landfills. This just gives you a photo of engineered landfills, which is built in the US. This I think this photo is from New Zealand, I believe. One of the landfills I designed. And I know in India there are landfills, which are, I said, 10 of them. They do have similar components. It's just we need more of those. We need more of those, which is proportionate to the waste produced in India with the number of people in India to be able to, have very little waste impacting the actual environment. Like you saw, 30% is not collected right now, and almost 90% goes to dumps, doesn't go to engineered landfills. This gives you an idea of a big landfill in near Los Angeles area. This is one of the biggest landfills in the US. This is a line that you can see exposed, a plastic liner here, and you can see the garbage trucks here. And this landfill is huge. I don't know how many hectares this landfill is, but this is 10 times bigger than a typical average US landfill. This is a gas pipeline. You see in the arrow here, the red arrow in the middle there is a big pipeline. This pipeline is 6 foot diameter. This carries the methane and CO2, which is generated in the garbage, to a big energy plant where where it is burned, and it supplies about 100,000 households electricity every day. This is how much electricity is produced here. These are the natural hills in near the Los Angeles area here. This is where behind that is the U.S. Air Force Base here, on the other side. And this is a valley between the mountains, which is filled with the engineered liner. So this is engineered landfill at a huge scale. Now India does not necessarily need such big landfills, but India does need more of smaller engineered landfills for sure. Let's see. This is a photo of gas to energy plant where the gas is brought in from the landfill and is converted to electricity, and it can power a lot of homes nearby. And so this is really a more sustainable way of managing waste. So when that waste is leaked, it is not collected. You're losing that resource. You're losing that resource, and it's really in terms of managing leachate from the landfills. I'm not sure. Maybe I can explain this concept in a very simplistic way. I know this is getting very technical for some of you who may be from a fairly remote fields, but one of the things about engineered landfills is they're going to generate leachate, and because you got a liner, you're gonna all the fluids in the garbage which contains contaminants are going to in the leachate. That leachate cannot be just discharged to a river. It has to be treated. But in India, with the weather being almost just 3 months of rain and 9 months of no rain, it's a perfect place to apply a technology called blanket, recirculation blanket. So I designed many of these blankets, and there is no Indian patent on this. I have US patent on this technology. There is no patent, so any country can use this technology, and I encourage everybody to use this technology to manage leachate, and because it's very easy to implement, where you can use recycled materials like glass. This is a recycled glass you see in front of you. A blanket is made on top of a landfill, and there's a pipe in the middle, and that leachate which is produced in the landfill is injected back into this permeable layer, which is in this case is made up of glass, because glass is very cheap in the US. Once it is recycled and crushed, it has very little value. So it is brought to the landfill, and it is put in a layer, and the leachate is put back into this, pumped into this layer. So this layer distributes that leachate uniformly, like you see that picture. This is that layer of glass. You see the picture, I have a pipe in the middle. So my patent basically was about this technology of this building this layer with a one pipe, instead of having multiple pipelines, multiple trenches, my technology made it very easy for anybody to recirculate leachate in the landfill or any other system where it gets treated automatically. So by injecting that, you're distributing the leachate in the landfill, and you are causing more gas generation, which that gas generates more energy, and the garbage settles more easily. When it settles, you create more room in the landfill. So the life of the landfill is increased. That means you can have more waste in the landfill. So all in that footprint, you can pack a lot more waste, and you can reduce the emissions substantially. So this is a recycled glass blanket. There is a lot of potential in Indian landfills to use this technology. So not a single drop of leachate has to be treated. It just goes back into the landfill and converts into gas. And that can decrease the cost. I have built several of these blankets in the United States. This is one of the largest blankets I built with shredded tires. Shredded tires in the US have no value because there's metal wires in them. It's extremely expensive to process them, to remove the rubber part, to convert into playground material grade rubber. It's very expensive. Like in the United States, they sell mulch made up of rubber tires, but it cannot have any wires in it. So it's very expensive mulch. So a lot of times these shredded tires end up in landfills. So my technology allows that blanket to be generated out of these shredded tires, and you inject leachate back into the landfill, and you spread it very uniformly, and you can collect the gas from this blanket also at the same time, enhancing the gas collection efficiency and reducing the emissions of this gas from landfills. So you have the technology right in front of you, which can be implemented at a relatively cheap cost to decrease the emissions. Yeah, this is another photo of one of the blankets I have built when I had tested my patented concept. You can see the wires here. There are sensors in this blanket and in the landfill to test the hypothesis I had developed at that point, that this blanket idea is way better than other conventional methods. And this was a test bed at that time. This is a very old photo. And all of the photos I showed you, these are actual technology being implemented at landfills where you don't need sensors to do that anymore because it's proved that it works. So the concept is really, taking the leachate which is generated at the bottom of the landfill, putting it back into the landfill to enhance gas generation. And this leachate then, because India is so dry for 9 months, you're going to have very little leachate generation here if you manage it by recycling back in the landfill. So this will prevent contamination of the rivers, the stream, the creeks, where the leachate ends up in the landfills. And this is really, I think, something could be taught in the classroom to students to broaden the participation of students in this type of technologies. This is just a photo of the blanket which I showed you with sensors. Now, the reason I'm showing this photo to all of you is some of these technologies you can develop yourself, and you have the power of sensors in India with the computer science background students. This sensor data from the sensors can be visualized, can be managed to come up with new technologies, come up with new concepts that can be patented in India and used for sustainably managing the resources of India. I'm going to switch gears from now waste to water. When I go to India, I go to conferences. I had a couple of postdocs who came from IIT Madras recently, and they worked with me on a project where we were looking at, groundwater depletion. And this project was not about India. It was really about a project in the US. But we're trying to generate a mini project in India because India, definitely there's a water shortage in some cities. Some cities have no problem. And I'm going to show you a map which will make things kind of put in perspective what is going on pretty shortly. So the picture I'm showing, I know, is not happening everywhere in India. This is an extreme heat and extreme parts of India there is problems like this. However, this could become a common scenario in a few decades if nothing is done about understanding the groundwater loss. What I'm referring to here is I actually looked at some data from literature and I kind of did some calculations. And I converted this into a graph, okay? So I'm going to try to explain the graph to you. So some of the information came from this site in India. This is a non-profit body. And then I did some number crunching myself to look at what is going on in India. So if you look at this y-axis here, this is the total water demand in billion cubic meters. Okay, billion cubic meters is 10 to 9. Okay, so this this blue line represents where we are today. Okay, so you can see the irrigation in India is going up, obviously, and then this is the water usage. Irrigation takes the most amount of water. Okay, you look at the water used by energy industry, like the power plants, the industry, consumption at your home, etc. Those are right here. If you add all these black lines and add the red line, you get the blue line. This is the total demand. Total demand is 810 billion cubic meters as of today. Excuse me. It is supposed to hit about, over 1,000 in about another some 20 years, some 20, 25 years. However, remember the water in India is not going to increase. So the demand is increasing. The irrigation definitely is going to go up substantially because the loss of water during the irrigation is substantial for evaporation. Especially as the temperatures are going up, this is going to climb up very fast. So this is a very conservative projection. I'm not sure if this is realistic. This could be a lot more or may not be as much, depending on how much temperature increase you're going to see in India because of global warming. And right now it's just a prediction. We don't really know exactly which way it's going to go. We know for sure it's going to increase because of the population increase and some temperature increase, for sure. So when you look at these numbers, you see this is the rainfall in India. So this is 2000, this is 2014. What you're looking at is, where is my legend box? Okay, so what you see is the blue, the orange colored bar is the total precipitation. And I think these other 4 bars are showing you every 3 months, so every quarter in that year how much is produced. You can see the monsoon season is the blue bar. So in those 3 months, most of the Indian cities get predominantly the rain. Rest of the 9 months, very little rain occurs, okay? But what you see here is, there is no increase in rainfall here. There is no decrease either. I know this is only a 14-year window here, but clearly you're not going to get more water from nature, but you're consuming a lot more water. And if the water is impacted with contaminants, if the waste is not managed properly, some of that groundwater may not be suitable for consumption. That means you have to resort to bottled water and very expensive resources. So this is the challenge here, is you're not getting enough water, but you're going to be consuming a lot more water. And when you combine that effect, so while the demand is growing due to global warming, then of course demand is growing also because of population growth, loss of water due to evaporation is also increasing. Why the evaporation is increasing? Because the air temperature is increasing. When the air temperature increases, things dry up very quickly. And you have to replenish it. When they irrigate the crops, they can have a lot of loss of water. And that means they have to put more water. The main effect is this here. So this was a paper published recently by a group of researchers. Actually, a couple of these researchers are from Michigan State University, my previous employer. And they worked with some people from Stanford and some people from Harvard. It was a big team of researchers who focus on water resources in India. And I just kind of put that in perspective by making some of the calculations I showed you. But what they're showing you is, of course, the darker areas with the brown color means less, deeper groundwater. So this is the groundwater depletion here. This is the depth of groundwater. So when you see blue, that means it's good. Blue is good. White means you're kind of going towards a decreasing trend. And when it becomes very brown, the depth is too much. So, can you guys hear me?
Yeah, please go ahead.
Okay. I think I have another 15 minutes, so I should be wrapping up pretty shortly. I know online presentations are hard on audience because I'm not present there in person, but hopefully you can, handle another 10 minutes, and I'll open the floor for questions. So I just want to show you where, Raja, where you guys are located. Are you able to see my cursor?
Yes, sir. Yes, sir.
Okay, so Raja, if I understand, is here. Is that correct? I mean, you guys can correct me because you are right there. Is that correct, this area roughly?
Yeah.
Yeah, so you can see Rajam is not in bad shape at all, but there is some brown color you start seeing here. the groundwater being depleted here, but this is a neutral area, white. And as you can see, the big cities like Mumbai and some parts of Gujarat, they're drying up pretty fast. The coastline is neutral. You can see there's more water because there's more rainfall here. The blue patches are, there is, the brown is increasing as you see to 2050 and then 2070. So this is the depletion problem I'm talking about, which definitely needs to be managed now.
Is there any reason from the comparison between West Coast to East Coast?
You're talking about comparison in Indian West Coast and East Coast?
East Coast, yes.
What is the difference you're saying? Why there is a big difference?
More depletion in the West Coast and more scope is there on the East Coast?
Yeah, because I think the population density, a lot of industrialization here.
Down south to Kerala.
Yeah, the Kerala, this part of Kerala is okay near the coast, right? You can see the white strip here because there's a lot of rainfall here. So as the rain drops off and the consumption is still high, then you're gonna draw down the water table. So this is the depth of water table. This is the change in the water table. Basically how many centimeters of drop you're gonna see in the water table.
Do you see any reason of the Western Ghats coming up?
Say that again. I'm not following your question. Maybe you're saying why there is more depletion.
Is there any influence of the Western Ghats over there? Highly dense Western Ghats?
Western Ghats?
Western Ghats, yeah.
I'm not sure which area you're referring to. Are you referring to the Maharashtra part?
No, the brown region right from top to bottom on the west coast. Is it because of the Western Ghats spread over?
I think it's partly because of the rainfall they get is not much to start with, while the population is a lot more. So it's a combination of, there are three factors coming in this map. One is how much rain is occurring in that land, how much is the air temperature increasing in that area, and how much is the population density. The higher the population density and the higher the temperature increase, you're going to have more depletion. Especially if you have lower rainfall there, then you're going to see more brown patch there generated. So it's a net effect is what is mapped in this by these researchers here in this paper.
And also groundwater intrusions.
Say that again.
From the sea to the land intrusion, underground water intrusions.
Well, yeah, this doesn't. So the underground water intrusion is going to be salt water intrusion. This is only talking about. The potable water, that means the groundwater recharge, which is coming from top down, not the intrusion from the bottom.
Okay.
That I don't think so, because that seawater is not. When the water becomes saline, and I was actually in Shirdi, as you know, Dr. Prasad. I think I was in Shirdi and I was talking to some farmers there. Their water table is depleted so much that they're putting now salt water, and they cannot use that on their crops. The crop yield is decreasing because the well is drawing salt water. When you go too far deep, you're going to have salty water in the ground, which is of no use for irrigation as the salt concentration increases. So what can we do about it? What is the pathway to the sustainability? Well, grey water collection and reuse. That's one. A lot of the water which is, now you saw the map, the consumed water is not much. The irrigation is a significant portion. And the irrigation, I know the farmers in India are already using drip irrigation. Drip irrigation technology was developed in Israel. Israel is the leading country in the world for reusing water and using every drop. Now Israel gets a very small amount of rainfall compared to India, but every drop is used in the farms or consumption by recycling it. Because, and you go to Israel, you will not feel like it's a desert. They got nice farms, beautiful farms, all sorts of fruits and vegetables growing all around the year. Very intelligently developed system. So India can do that. I know India gets a lot more rain than Israel. And however, India's population is more, but if we recycle most of the water, especially the grey water can be used for toilets and irrigation of gardens and farms. You can save a lot of water. And the grey water will reduce the burden on the wastewater treatment plants, which if they're not properly operated, that wastewater leaks into the river. So by recycling the grey water, I think is the really way. This is where the AI can be very powerful, because you can develop a pipeline network for the AI, which is going to be the most optimum network for the highest collection and reuse. And a lot of rainwater should be stored in the rain gardens. You can use green roofs on the buildings. In India, a lot of buildings are concrete buildings, which is really very conducive for green roofs. In the US, a lot of homes are made up of wood. So you really cannot have a green roof because the green roof is very heavy. This green roof on the top of the building can decrease your air conditioning cost. It can make the buildings cooler naturally. It can save a lot of resource, and it will decrease your temperature footprint. So some of these technologies I'm going to rush through because I'm approaching 7:50. What is this time? Is almost 10:15 there. When you're having fun, the time flies. I didn't realize that I'm keeping you in your seat for 45 minutes there, and I just keep talking. So the grey water, I don't know how much the grey water uses in India, but it's basically using the water from our bathrooms, sinks, clothes. It's not the toilet water. It's not the toilet flushing. It's only the all-other water, which can go into a storage, and it can be used back in the garden. Or if you use a biofilter, in India there is a lot of potential for this. That water can be used back in the toilet system again, because this cannot be used for drinking or anything. But this water you can keep recycling, and you can decrease your discharge water substantially by recycling your water that you consume at the household level. To me, the grey water reuse is big in Israel. Even the US, they don't use any grey water yet. In some cities, they are thinking about it because US has plenty of water right now. But I think those days are numbered. Stormwater, a lot of stormwater. I know this photo is from US. If you can store that in the ground using rain gardens, you can use this for landscapes, and you can save a lot of cost, and you can decrease your air temperature substantially by reusing the water. And some of these technologies, actually, I was doing a presentation for some African countries because Africa has serious water shortage. Whenever they get a rain, which is very little, this concept of gravel dams, in building this gravel storage reservoirs in the ground, you can create like an aquifer basically. You can create an aquifer in the ground, so when there's a rain, these gravels create storage of water, like an underground tank almost. It becomes like a natural tank where you can store the water, and then you can pump that water out over the year to use. Because a lot of times in Africa, the water just evaporates since it is not going into a storage like this, or it goes to rivers and goes to the ocean. They don't have the storage for it. So you got to create storage for your rainwater near the communities where the water is landing. So it can be reused very easily. Green roofs, like I talked about, should be taught in the classroom. Green roofs to me is an architectural type of knowledge, and that should be brought into classrooms. And then like in India, if you go to Prestige University in Indore, they have a green roof. And I know there are several green roofs in Bangalore and other cities, which a lot of times they are only done at a commercial scale. But this needs to be applied at a residential scale. A lot of these apartment buildings in India need to have a green roof on top where the terrace is. So that should be built into the design of the building. So these buildings will be cooler, a lot of rain can be stored, and it has a lot of environmental positive impacts. So with that beautiful picture of a green roof in India, I'm going to end my presentation basically saying that the urgency for priority change is important. And you all sitting in that room are the leaders. You're the leaders in your discipline. I want you to take some of this and convert into anything that can motivate people who are in your classroom, the students, or the government employees. Or if I can be of any help beyond this conference, you just get in touch with me by email. And I'm there not too far to help you. But that's my vision for environmental sustainability. So if you have any question, I don't know how much time you have. I know you're sitting in your seat there. You need probably a break for tea or something and stretch your legs. So I won't hold you too long. But if there are any couple of burning questions, maybe I'll try to answer those.
Thank you very much, Professor. And right now it's open to queries to the audience. Any questions, please? Online as well.
Good morning, Dr. Milind Khire and Dr. P.N. Singh. I have only that your project boundary has reached to the northern plains of India or not, because the 8 districts of the northern India, Trishikamadi, Madhubani, Darbhanga, Jayanagar, due to this non-network of the rivers, North Indian rivers, the Ganges, the Budi Gandak, the Gandak itself, Narayani Nadi, and main the Tejas river, the Koshi. So you will be surprised to know, or might have visited already, but I have not seen in that part is that there is 8 months water and water only everywhere due to the non-network. So how those plants can be improved by the government of India to make use of those grey water or rainwater, where there are 8 months of water only. Thank you.
Let me make sure I understand the question clearly, because there was some echo here at my end. So you're saying a part of India where you're referring to, northern India, there is 9 months of rainfall, is that correct?
No, not 9 months of rainfall. Rainfalls are 4 months only, but 8 months of water logging of the flood water. I repeat, if you can hear me clearly, so 8 months of water logging due to the flood water in the 8 districts of the northern plains of India.
Okay. So,
and it is main cause is there is no network plan or not implemented yet for the making the network of rivers, all coming from Himalayas, from Nepal, the Ganges, the Budi Gandak, the Koshi. So it is a surprising thing that now in this 21st century also, that our 8 rivers are not having the network, causing 8 months of water logging without reuse of that water in 8 districts of the northern plains of India.
Yeah, so I think you're talking about the water logging. That means the water is not really used by, there is no proper storage for water. This water, I mean, this kind of project can be major projects for the government. This is not a bigger project.
Professor, he is asking about, Professor.
Yeah.
He is asking about networking of those rivers, because probably the networking of those rivers might mitigate the problem of water logging problem, because of the 4 months long rain over there, and because of the floods that are happening, the water is getting logged and the people are suffering for 8 months.
That is correct.
That is because the water is getting logged in between and then not being properly networked for the proper drain out.
Correct. But some of it is related to building dams, right? Where the water is, from the rivers. I don't know the topography exactly, because this question is a little bit hard for me to answer, because without knowing the region, how the rivers are set up and what the elevation changes are. But clearly, this is a problem where you're talking about the amount of water is generated in those 3 months is so much, and that water is basically going in an area where it should not be. So, but I'm sure there is some areas where there is drought. So this water which is generated, if it is stored in dams or through the networks of the river you're talking about, you're saying it could be a distribution network, right? This water could be transferred into other parts of India. Isn't that what you're talking about? Where it could be used.
It can be channelized. They can be channelized.
Yes, it is government plan to make the interconnection of the rivers.
Interconnection of the rivers, again, that depends on the altitude where they lie,
Yes.
and the flow pattern. And the one thing is they can be channelized for effective utilization.
No, I think what you brought is this comes to my mind. So California, as you know, is very dry state where there's a lot of people living, there's a lot of economy there. But California gets a lot of water not from California. It doesn't have the rain. So California gets water from as far as Colorado through rivers which are channeled like you're talking about. So yes, India would need channeling the water. It would need, basically the water cannot be, whatever area is getting flooded, that water has to be pulled out by channels and by dams or by creating a network of pipes which are connecting the other cities. And that is a major project. That's a major infrastructure project, obviously. But some of this conference is about AI power, right? So what could you do with the AI? Could you look at the topography? Could you come up with solutions which are optimized for cost? How would you connect these rivers? What would be the ways you can connect these rivers so the cost of this physical infrastructure is, can be optimized. And this water can be distributed to areas where they need, rather than getting flooded, it can be distributed to areas that are flooded. So I think you clearly already identified the problem. And the solution of that will require a major infrastructure project, but what you can do with AI is finding a solution which is optimized. So it's optimized in terms of what the zone usage has been, where the impacts are the most, and where the need for this water is the most. When you combine that, it becomes an optimization problem. So I hope I know this question maybe I'm answering at a very high level because it requires so much detail on the ground to know before I can answer it more in a technical sense.
Yeah, that is true.
Is there any other questions you guys have?
Yes, sir, Professor Kiri. I have two questions for you. That is, the first one is, as far as the plastic is concerned, pole to pole, that's the biggest problem across the globe. So how to handle this and what kind of better entrepreneurial opportunities are there, in India especially, other than the recycling? And my other question is, as far as India is concerned, population is exploding. So how to utilize this land? Because land is very expensive because population is exploding. So how to offset this one? These are the two questions, sir.
Yeah, you asked very good and challenging questions, honestly, because the first question, especially what you brought up, is true across the board. It's not just for India. Because we are so attached to plastic. There's a plastic cup in my hotel room here, but then there was a company, Remia, who I met yesterday. They convert everything. They're replacing the plastic cups with bamboo, which looks like bamboo. It's not natural bamboo. It's basically paper and the actual wood fibers, and converting into cups, which are fully degradable. Now, those are expensive, however, because the cost of plastic is so cheap because there is so much infrastructure we have built around plastic that buying a plastic cup is a lot cheaper than buying anything else. It's cost-wise cheaper not only for the production, also transportation because it's so light, but is plastic really healthy? It's not really healthy because plastic does leach and you got microplastics in your water that you're drinking. So most of us have microplastics in our blood, and that's a fact. How can we decrease it? Well, I don't know whether we can decrease that anytime soon very quickly, but we have to change our lifestyle, from using disposable type of economy to something where, we change the lifestyle, we change the way people think, the social interaction. And I know a lot of companies are trying to do that, but this problem is a much bigger problem for me to answer. I think it needs to happen at the government level. Like in California, you cannot use a plastic grocery bag. It has to be a paper bag. And many states are following that. The paper bags are more expensive than plastic bags. But the grocery stores, they're just adding that cost to the food they sell. So you're paying for it. I know in India also they're doing that. They're banning a lot of plastic bags because these plastic bags end up in that 30% garbage which I told you is leaked. It is not collected. That leaked garbage on the streets, when it rains, that plastic flows into the stormwater drains. It blocks the stormwater drains and you get flooding in the city. So to stop that, they actually stop plastic. And I don't know how successful it is in Indian cities, but it has to happen at the household level. You have to give people less and less plastic options. Then only people will change their mentality. If you give them an option of plastic versus non-plastic, they will still pick plastic because plastic is very convenient. You have to eventually start terminating those plastic options, or you have to make people pay a lot more for plastic, just like other countries are doing that. So it's not an easy fix. It is definitely going to cost the consumer more in the upfront, but as time goes on, people are going to change their lifestyle around plastic without using plastic, and hopefully that will be the day we'll see less plastic going to the landfills. And until then, plastic should go to landfills, not on the streets. It should be burned. Burning plastic can create extremely toxic emissions. So it must go to landfills where it can be eventually mined, maybe after 50 years when the cost of plastic and plastic has room for something else, not for making cups, but maybe making some industrial products, which are not disposable. You don't want to dispose them. So obviously, the question you asked is a very important question here. I do not know what happens in the Rajam area, the part of India you are in. What are the regulations on plastic? Do you see anything changing? But it has to happen at the municipality level for people to start thinking about the use of plastic. I'm sorry, I lost your second question. What was your second question you said?
That's regarding the landfills. Population is exploding in India, so how to utilize landfills to the fullest extent possible?
Investing on landfills. We are on the population growth we are talking about, right?
Yes, the population is exploding. So how to utilize?
Yeah, I think as the population is increasing, we need to produce less disposable garbage. We should be producing more recyclable garbage. We should be more, all the degradable fraction must get composted and come back. But there is no way out on population increase. I mean, that challenge is going to be happening for every country. Every country is going through population growth, maybe except Japan. I think they are losing their workforce. But a lot of countries are exploding population, so this is a global problem. And I think as far as waste is concerned, you will definitely need more landfills, but those landfills can be managed in such a way that they are not like dumps. They're not managed with a very short lifespan. If they're managing a landfill, they can put a lot of waste which is not degradable, which is not recyclable. We have no choice, but it must go to landfill. That should go to landfill. But all other fractions should be recycled or reused. And that fraction needs to grow as the population grows. So at a normalized level, the population has no net impact on increasing garbage consumption because we're increasing our habits for more recyclable garbage. I know we're at the top of our hour.
Professor, I have a last question.
Yeah.
You were talking about biodegrading and all. So, is there any work going on accelerated biodegrading with AI getting in?
You're talking about accelerating degradation of garbage?
Accelerated biodegradation with AI coming in.
Okay, so no, the air is called aerobic. So when I talked about the composting, the biodegradable fraction, so the biodegradable fraction of waste, if suppose my vision comes true in India, there is 3 garbage bins. One is that food waste, a degradable fraction, goes into that bin. Now that you can aerobically decompose, and that's what we call compost. Compost is aerobic decomposition. You usually don't need to pump in air. I mean, you could, but you basically need to shuffle the garbage in a composting plant where the air is used to degrade the waste. But the stuff going to landfill is anaerobic usually. Anaerobically also waste can degrade. And to make it degrade fast, you need more moisture. And this is where that recirculation technology I talked about increases the rate of degradation in landfills by increasing the moisture content of the waste. By distributing the moisture uniformly, you can increase the degradation rate.
Sorry for interruption, sir. What sir meant was integration of AI, artificial intelligence,
AI, not air, AI.
AI into waste management.
AI in bringing out an optimum biodegrading environment to accelerate it.
I am not really sure how AI can be used for, I mean, because the degradation phenomena is well known. The only thing
multiple factors, you have multiple factors, right? For biodegradation.
Say that again.
There are multiple factors for biodegradation, right?
Yeah, in multiple materials. You're talking about the heterogeneity of waste, where you got all different materials which are degraded.
There are multiple factors, probably there could be a, I don't know.
Yes, definitely, you're right there. There are various factors to optimize the degradation. You know, AI could be used depending on the composition of waste, the environment of the waste. That's what I think you're referring to, correct?
Exactly, yes.
I agree with that. I definitely think AI has potential. I'm not an AI expert per se, but I think that there's a lot of potential for optimization. Anytime there's optimization, you got multiple parameters involved. I believe that AI can do the job because it can do a lot of permutations and combinations much faster than humans can do. So I think definitely there is a room, and maybe some of the researchers sitting in the room maybe already are thinking, this could be a very good student project for them to give some data to students and start playing with the AI algorithms.
Thank you.
Thank you very much, Professor Milan Makiri. That was very insightful concerning the ground reality in India as far as the presentation is concerned. Thank you, sir. Now I request the audience to have refreshments and go to their respective sessions in Block 3.
So, sorry, I didn't understand. So, I think that concludes my presentation, right?
Yes, sir.
All the best for the rest of the conference. It was really a pleasure to see you all there in the room. wish I was there in person because I miss the Indian food and the Indian tea. You know.
Thank you so much, sir. Have a nice day.
Okay. All right. Bye now.
Thank you, sir. Bye.